Hi everyone. So we are now moving into factoring polynomials. So we're going to do two things. Factor by grouping is the first. So I want you to pause the video and factor those two problems. So the first one is an MC chart. We are multiplying to negative 48, combining to negative 8. If you can think of it in your head, that's awesome. If you can't, make your chart. 1 times 48. 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Since we're multiplying to a negative, combining to a negative, we need a negative. The bigger number is going to be negative. So our two numbers end up being 4 and negative 12 because they combine to negative 8. So we get x plus 4, x minus 12. The second one, that's a dots. Right? What times itself is 16x squared? 4x times 4x. What times itself is 49? 7 and 7. One's a plus, one's a minus. Okay, so we are going to be doing something called factor by grouping. Factor by grouping is a method where we have more than three terms. So we're going to have 4 terms. And we're going to do a GCF twice. Typically, the steps involve a GCF that is a monomial, followed by a GCF that is a binomial. So remember with GCF, let's say we have 2x squared plus 6x. Remember GCF, what can we divide by? In this case, I can divide by 2x. I divide, I get x plus 3, parentheses, put the 2x on the outside. Another example would be x cubed plus 4x squared, right? What would the GCF be there? X squared, right? Take the bigger exponent. When you divide, you get x plus 4, parentheses, GCF on the outside, okay? Okay, so this is what these look like. So what we're gonna do is you're gonna do a GCF with just the first two, and then a GCF with the second two. So why don't you try that? So the GCF for the first two, we have x cubed plus 6x squared. Notice I did one just like that on the last page. The GCF here is x squared, right? When I divide, x cubed divided by x squared is x. 6x squared divided by x squared is 6. Parentheses, we put our GCF on the outside. So that's the first two. Now I'm going to do the same thing with the second two. What's the GCF for 2x and 12? So there's only x's in the first one, so there's no x, it's just a 2. When I divide, I get x plus 6, parentheses, a 2 on the outside. Now, notice we have x plus 6 in both of those. So what we're actually going to do here is do a GCF of x plus 6, right? So that second GCF is always a binomial. So if I divide both of these by x plus 6, so my GCF is x plus 6 because I see it twice. Those cancel out, and I'm left with just the stuff in front. Okay. So here's another example. I'm just going to make up one similar to that. So if I have 5 times x plus 3 and x times x plus 3. X plus 3 is my GCF. So basically, if you can think about it, I'm going to take the x plus 3's out, put them in front, and then what's left over when I take the x plus 3 away? We're left with the 5, and we're left with a plus x. Okay? So why don't you pause and try the GCF of the first two again, right? GCF of those two, and then GCF of these two. Same process. All right, so I've got the GCF of 2 and 6 is 2. X cubed and x squared is x squared. Divide, and I get x plus 3. Parentheses, put my GCF on the outside. And then over here, my GCF is 7. So I have 7, and then when I divide, I get x plus 3 again. These two have to be the same. For this process to work, they have to both have x plus the same binomial, right? So then we take out that x plus 3, right? X divided by x plus 3. That's a GCF, so that x plus 3 goes in front. And then what's left over when we take that away? We've got our 2x squared and our 7. And that's your answer. All right, try the next one on your own. So pause and try it. Okay, so the one nice thing with factor by grouping is it's the same thing over and over again. It's the first two, x squared times x minus 7. And notice the first one, it's always an x squared first and then a plain number second. So it's super consistent. Right, take out the 2, x minus 7. And then we take out the x minus 7. X minus 7, x minus 7. So when we take the x minus 7 out, that's our GCF, and we are left with, this x squared and the 2. X squared plus 2. All right, try the next one. Now this one is a little harder. We're going to have one extra step on this one. All right, pause and do it. Just watch me. GCF of x squared. So x squared, x plus 5. And then what's the GCF for the second one? Okay, so now this one, it's not just 4 though. See how this is a minus? Anytime that's a minus, your GCF is a minus. So my GCF is negative 4. So minus 4. And then what do you get when you divide? Negative 4 divided by negative 4 is 1. So 1x. Negative 20 divided by negative 4 is plus 5. Okay. So then when I divide, I'm going to divide out that x plus 5. Right? X plus 5, x plus 5. So the GCF up front is x plus 5. And then what's left over when those go away? We're left with that x squared and the minus 4. Now, I said there was another step. What's the next step? Look at what we got in the parentheses. We have x plus 5, and then we have x squared minus 4. We know how to factor that. That's a dots. If you look back, all the other problems we did, they weren't factorable. You couldn't do anything. This one you can. So we got our x plus 5 out front, and then difference of two perfect squares. X times x is x squared. 2 times 2 is 4. 1's a plus, and 1's a minus. Right? All right, I think these are the last two. So pause the video and do both of these. All right, these are a little harder, right, because the GCF is slightly harder. All right, what's the GCF of 8 and 12? So that's 4, and we have x cubed and x squared, so we got x squared. So 4x squared, when I divide, I get 2x minus 3. The GCF for the second two, 18 and 27 is 9. But remember, anytime this is negative, our GCF is negative. So it's going to be minus 9, and then 18 divided by 9 is 2. And then 27 divided by negative 9 is minus 3. And that's helpful because now we have 2x minus 3, 2x minus 3. If one of them was, say, a plus, this wouldn't work. They have to be exactly the same. Divide out the 2x minus 3's. Those cancel. So I get 2x minus 3. And what are we left with? We had that 4x squared minus 9. And then we check. Can we factor again? Do we have a dots? And I'll tell you right now, it's always a dots. It's either a dots and we can factor again, or it's something weird and we're done. Right? This one is factorable. So 2x minus 3. Right. 4x squared, that's 2x times 2x. 9 is 3 and 3. One's a plus, one's a minus. So we actually end up with 2x minus 3's. All right. And number 6, again, the first two is 9x squared. That one's pretty straightforward. X plus 2. Now, this next one's a little trickier. What's the GCF of negative x and negative 2? Again, remember I said that since this is if that's a negative, we need a negative. So the GCF is just negative 1. So negative 1 and then x plus 2, making both of these have an x plus 2 in them. Cancel, cancel. So x plus 2, and then what are we left with? What's our other binomial? 9x squared minus 1. We ask ourselves, can we factor? Is there a dots? There is. So x plus 2. What times itself is 9x squared, 3x, and 3x. 1 times 1 is 1. We've got a plus and a minus. Oh, I lied. This is the last one. This is the last page. So pause. Try these on your own. All right. So we got x squared. I'm going to do this all in the same pen this time. And over here looks like negative 4. And actually, if you notice, this ends up being the binomial. I just noticed that actually. So the binomial that we end up getting is going to be x squared minus 4. But we really do need to check that we get the same inside, because if we get something that doesn't work, it's different, you actually can't use this method. So we get 2x plus 5, and then 8 divided by 4 is 2. Negative 20 divided by negative 4 is 5. So it does end up working. So we got that 2x plus 5 and x squared minus 4. And then x squared minus 4 is a dots. So x plus 2, x minus 2. And then number 8, again, same process, nothing different about it. It's actually going to be really similar to number 6. So we got our m squared times m plus 7. And then what's the GCF for negative m minus 7? Minus 1, because that makes it plus 7. Take that m plus 7 out, and we're left with m squared minus 1. And then last we have our dots. M plus 7. M times m is m squared plus 1 minus 1. Okay, so now what we're going to do is talk about what do we do if you try to do factor by grouping and it doesn't work. What are we going to do to factor? What we're going to do to factor is guess and check. Using synthetic division. Now we're going to start out where I'm going to give you some extra information. But basically, if we can't do factor by grouping, the only other way to do it is just synthetic division. We're just going to have to guess, all right? Today, we're going to keep it easy. I'm going to tell you what number to use, but in the future, I'm going to make you sit there and, figure it out. Okay. So our polynomial is x cubed plus 9x squared plus 23x plus 15. If you try to do GCF, factor by grouping, you get x squared and then nothing goes into that. So you get x squared, x plus 9, plus 1, 23x plus 15. So it doesn't work. It's not the same binomial. So this does not work, right? So what I'm telling you that x plus 5 is going to be a factor. If I factor this, I'm x cubed plus 9x squared plus 23x plus 15 is going to work. So we're just going to do synthetic division. So I'm going to write out my coefficients. 1, 9, 23, 15. And then what's my outside number? Change the sign so it's negative 5. Bring my 1 down. Negative 5 times 1 is negative 5. Write it underneath. Combine down. Negative 5 times 4 is negative 20. Combine down. Negative 5 and 3 is negative 15. Combine down. So we don't have a remainder. So now we have that x plus 5, right? So this time, instead of ignoring that, we're going to write that out because we're factoring. We're not just dividing. And then what's left over? X squared, 1x squared, plus 4x plus 3. Now with these, we do have one more step. What's the last? Look at what we have. Just like with the factor by grouping, we factored using dots. We can factor again, but instead of dots, what is it? This is an MC chart. This guy on the right that we got, that's factorable. What multiplies to 3 combines to 4? 1 and 3. Right? So typically what happens with these is you're left with an MC chart. Right? So x plus 1 and x plus 3, and that's our answer. Right? So we just factored that polynomial. All right, next one. So now you're going to do, again, synthetic division, just like regular division that we did the other day. So I'm going to change my x minus 3. The outside number is going to be the 3. So 1, negative 1, negative 14, and 24. Bring down my 1. 1 times 3 is 3. Combine down. 3 times 2 is 6. Combine down, negative 8 and negative 24. All right, so again, if we didn't get a 0, this problem would be a mess. Like, we have to get a 0 here, all right? So now, how do we write our answer? So we have our x minus 3 as a factor, right, because it went in nicely. And then we divided it out, and what are we left with? X squared plus 2x minus 8. And now last step is x squared plus 2x minus 8 factorable. It's an MC chart. Does anything multiply to negative 8 and combine to 2? Well, yeah, 2 and 4. Right? The 2 is negative. So our answer is x minus 3. And then I have my x minus 2 times x plus 4. And that trinomial, or polynomial, is factored. All right. Last one, little trickier because we have a fraction and a missing term. So this one's a little bit much, right? So what do we write on the outside if we have 2x plus 1? Remember, we set that equal to 0 and solve. So I bring the 1 to the other side and I divide. So we're going to put negative 1/2 on the outside. And then my coefficients are 6, 7. Our x term is missing. So remember, there's a 0 there. And then negative 1. All right. So we bring our 6 down. What's half of 6? 3. But it's negative because the negative 1/2. Combine down, 4. Half of 4 is 2, and it's negative. Bring it down. Half of 2 is 1. I have a double negative, right? Negative 1/2 times negative 2 is positive 1. So now we have 6x squared plus 4x minus 2. But remember, we have to do something. What do we have to do? We have to divide by 2. Right? So we have that 2x plus 1. And then we get 3x squared plus 2x minus 1. All right, so now here's the question. Is that factorable? Now, this isn't just a regular MC chart. This is a slide. Remember the slide? I wouldn't put this on a quiz, don't worry, but I figured we could go over it in class. So remember, for slide, it's an MC chart, but instead of multiplying to -1, we're going to multiply 3 and -1. So we're multiplying to -3, combining to 2. So 1 and 3, with the 1 being negative. So we get 3x minus 1, 3x plus 3, and then we divide. Which one of those has a GCF? 3x plus 3 can divide by 3. So our final answer, running out of space, we have our 2x plus 1, 3x minus 1, and then x plus 1. So that one was pretty hard, right? Again, I wouldn't put something that hard. I would give you this, but I wouldn't make this by grouping. That's a little mean. Or a slide problem, sorry. I wouldn't put that on a quiz. I might give you one with a fraction, though. Okay? That's it. Homework.